review, and then I will get into the compound or combined inequalities in about a minute. All right, the basic relationship is illustrated with transitive property of order. If A, B, and C are real numbers, if A is less than B and B is less than C, then by transitive property, A is less than C. If C is greater than B and B is greater than A, then you conclude that C is also greater than A. So that's common sense put into mathematical words. Addition property of order and multiplication property of order. If A is less than B, then if I add the same thing to both sides, the inequality relationship remains the same. If A is less than B, if I multiply both sides by the same number, the inequality relationship remains the same. The piece that may need to be reviewed from years past, multiplying or dividing each side by a negative number reverses the inequality symbol. It reverses the inequality. So that's a review from last year that is maybe worth mentioning at the introduction to this unit. Let's look at number 3 together. And the goal is still to isolate the variable. And I would subtract 4, add the opposite of 4 to both sides, leaving me with negative 2b is greater than negative 10. And now, the coefficient on the variable is negative. So I'm going to now multiply by negative 1/2. And when I do that, I will have b, instead of being greater than, b will now become less than. This reverses the inequality symbol to less than. So b is less than 5 would be the solution to a problem like number 3. Okay, word problems. Number 15. 4 more than the quotient of a number and 3 is at least 9. 4 more than the quotient of a number and 3. So the quotient of a number and 3 would be represented as 9, or I chose n as my variable, n over 3. The quotient of a number and 3, I'm representing that as n over 3, is at least 9, meaning that the smallest number this could equal is 9. So the inequality that I would set up would look like this. 4 plus n over 3 is greater than or equal to 9. And then I would solve that for n. 7 more than 5/6 of a number is more than negative 3. So 7 more than 5/6 of a number, and I will use n as my variable once again. So 5/6 of a number is more than negative 3. So that's taking the words and turning it into an inequality open sentence. Okay, now for something new. Continuing on in your notes. This is now page number 2. Compound or combined inequalities. So a little bit of vocabulary background first. Conjunction is associated with and a compound inequality that is a conjunction can be written as one entire string. A disjunction or a compound inequality connected with the word or cannot be written as a single string. The word or must remain in the equation all the way through. So let's talk about the solution set criteria, how they differ. When I am working with a conjunction, and conjunction associated with the word and, the criteria for finding the correct solution set means that both conditions must be true. Both conditions of the inequality must be true. If I'm solving a disjunction compound inequality, the solution set criteria is that at least one of the conditions must be true. And that really only matters whenever we get to the special cases, which I will show you. But for the most part, you're looking for the solutions that make both pieces true. But the technical definition for conjunction is both conditions must be true. The technical definition for disjunction would be at least one of the conditions must be true. Now the solution sets for these are actually continuous. So your solution set is a continuous range. So we're going to be shading on a plain number line. So your solution set itself will be a continuous shaded range for both. So SOL for solution, solution set, a continuous range. All right, let's solve one of these. So in a conjunction, you're still trying to isolate the variable, and the variable is in the center between the two inequality symbols. So I would subtract 1 from all 3 spots. X has been isolated now, so you can make your conclusion. And you can see that -3 is less than X, which is less than or equal to +3. To graph the solution, draw a number line, plot your boundary points, -3 and +3. -3 less than X is a strict inequality. So on the number line, it's represented with an open circle. X is less than or equal to +3. Since it's less than or equal to, that is a solid closed circle. And when you're graphing a conjunction solution set, an AND solution set, you shade all of the points in between the 2 boundary points. So your solution set is this continuous range between the 2 points. So it's a continuous range, and in this particular problem, the solutions are all the numbers greater than -3, not including -3, all the way up to +3, including +3 itself. That's what the notation looks like. Okay, let's solve the disjunction, the OR scenario. So you actually just solve each equation separately. So I have 1 + 5x is less than -4. I'm still trying to isolate the x. So I would subtract 1. And then I would divide by 5, so x is less than -1, or the word or must remain in. Solving this for x, I would subtract x and have 3x is greater than 9, and then multiplying both sides by 1/3, x is greater than 3. So those are my 2 boundary points. The graph for this, draw a number line. I have -1 and +3. X is less than -1, and notice that it's an open circle. So I draw an open circle. If x is less than -1, then I'm shading in the direction of -infinity. X is greater than 3, an open circle. X is greater than 3 implies I'm shading in the direction of +infinity. So this is my OR, the graph for a disjunction, and then comparing it to the graph for a conjunction with AND. You find your boundary points. When you're finding the solution set for a conjunction, you shade between the 2 boundary points. So here's your conjunction solution sets, shading between. When you're finding the solution set for a disjunction or the OR scenario, you plot your boundary points and then you shade in the direction of -infinity and shade off into the direction of +infinity. You have no overlap in the disjunction or scenario. They have no common points. And in the continuous range either lies between the 2 boundary points or the boundary points mark the number line going off in opposite directions.